Hello everybody and welcome back to another video by Funland Tutorials. Last week we looked at how to we looked at how the addition and subtraction operation works in complex numbers. And as I mentioned last week, today we'll be talking about multiplication. You might be wondering, if addition and subtraction were so easy, why didn't I fit multiplication and division in the same video? The reason being that I particularly find I have come across people who did get a little bit confused when I introduced division of complex numbers to them. So I will be dividing it into two videos. If you really want to find them out, just wait it a couple of weeks and you'll just get them at the same time. So let's start with multiplication. So let's go with the same complex numbers that we decided. So let's take a different color so that we get, make things interesting. So we'll be looking at the first complex number will be z1 plus a1 plus b1i. Z1 equals a1 plus b1i, and z2 will be a2 plus b2i. So these are the two complex numbers that we'll be taking into consideration. And when we talk about multiplication, what we'll be trying to find out is we'll try to find out z1 times z2. So that is what we'll be trying to find out. Now, to make things simple, let's write down what we have. So what is z1 actually? Z1 is actually, as I mentioned before, or as I have explained above this document, is a1 plus b1i. So that's z1. That's something that we know, right? And next, what we'll be writing is the expression for z2. So it's pure algebra. It's just, there's nothing too complicated about it. We'll just write this expression and make things visually clearer to us. So these are the two expressions that we'll be multiplying with. Now let's consider them to be an expression, a very normal algebraic expression. So let's say it was something like x plus y times uh, p p plus q. So let's say it was something of this sort. Let's say we had an expression like this. What would we have done? We would have multiplied them, or what you can do is you can write x and then you take a bracket and then you write p plus q. So what we are doing is we are actually breaking this bracket. If you want, you can break this bracket first as well. That does not change the answer. You can do whichever suits you, whichever you're comfortable with. So if you want, I can write the other expression that you might be looking for beside this. So you could have written instead, I'll be breaking this. I could have broken this bracket. So I could have written instead x plus y times p. So instead of breaking the first bracket, I could have broken the second bracket, and I could have written x plus y times p plus x plus y times q. Right? I could have written that as well. It doesn't change the answer, and it will actually be the same. I'll show you in the next step. What happens is I can break them apart, so I can get xp plus xq. So that is what I get from the first expression for the first bracket, and from the second bracket I get yp y plus yq. So that is what I get if I break the first bracket in my first step instead of breaking the second bracket. Now, do I get, if you're wondering, do I get the same thing if I do the other way around, if I do the blue step, right? Let's look at that. Let's take the blue pen and let's check that out. If I had done this, I would have got xp. Okay, so that we have that here. Then we would have got yp. We have that here as well. Then we would have got xq. Okay, that's here as well. Check. And then we would have got yq. So check, right? We would have at the end of the day we would have got the same thing. So whether we take this step or whether we take this step, that doesn't matter. Now, why did we do so much? Thing is, instead of looking it as complex numbers, we can look at it as and just plain old algebraic expression as well. So now what I'll be doing is I'll be just doing this, and what I'll be doing is let's skip this step. So what we'll be doing is x times p, x times q, y times p, y times q. So we'll be doing a1. So let me use the blue pen, and then we'll be doing a1 times a2. So let's do that. I'll be doing a1 times a2. So I'll be writing a1 times A2. Then let me remove this, or maybe let's keep that so that we know what we have written and what we haven't. And let me make things smaller so that I can keep everything on screen at the same time so that you know what we are doing. Okay, so that's first term done. Next, we'll be sticking to the first term in this bracket and we'll be moving on or switching on to the next term in the second bracket. So I'll be multiplying A1 with B2I. So let me write that down once. So A1 B2I. So that's our second term done. Now let's move on to the second term in the first bracket. So we have B1I and we'll be multiplying that with A2. So let's do that. Now, what I usually advise people is that when you're working with so many algebraic expressions, or when you're working with so many algebraic terms, x, y, p, q, here we have a1, b1, a2, b2, try to stick to an order. So if you're talking about these expressions, a1 comes before a2, a1 comes before b2, b1 comes before a2, well, A2 comes before B1 because A comes before B, so A2 comes before B1 and B1 comes before B2. Now, why I mention that is there are some times when, let's say, there's this long expression and somewhere you have written B2 B1. Let's write that properly. Somewhere you have written B2 B1 and somewhere else there's down this road you have written somewhere minus B1 B2. Now you keep looking for terms and you don't realize that I can cut these two. So what happens is sometimes we are left with these and we actually end up using a lot of steps when we could have done all of them at the same time. So what I usually advise people is to stick to an order. So if I do that, if I stick to an order, then A2 comes before B1. So instead of writing B1 A2 as I would have normally, I am writing here A2 B1I. And I prefer writing I at the very end. So I'm not writing A2 I B1 or something of that sort. So I'm writing A2 B1 I. So that is what I'm writing. Let's move on to the final, last but not the least expression, or the last but not the least term. Let's look at B1I plus B2I. So now what we can do is I times I. We will not be skipping a step here because this is sometimes a little confusing. So what we'll be doing is let's write B1 I and then I'll again write B2 I. Now if you are comfortable with it, what we can do is, let's say I have x y into p y, right? Let's say I have this expression. I can write this expression as x p y square, right? I can write this because there are two y's, so y times y is y square. So I can write this. I'll be using the same concept here as well. So instead of writing b1i times b2i, what I'll be doing is I'll be simply writing b1, excuse me, b1 b2, and instead of writing I times I'll be writing I square, right? Now there's this uh, the part where we start, we remind ourselves that we are doing complex numbers and we are not doing just plain old algebra, right? We are doing complex numbers. So let's remember something. Let's remind ourselves that I square, I will, if you're confused about this, I will be explaining this in brief in today's video. But if you want, I'll be linking the introductory video on complex numbers somewhere on the cards right above here. And I'll be also linking them down in this description box below. But basically, we know that I square is actually nothing but minus 1. That is where the entire concept of complex numbers originate from. I square is minus 1. So instead of writing I square, what I do is I consider this to be minus 1. So it's b1 b2 times minus 1, which is nothing but minus b1 b2, right? B1 positive plus b1 b2 minus into minus 1 is actually minus b1 b2. And now from these two terms, we have this I term. So what we do is we take this I common, or if you want, you can put the I at the end of the bracket as well. And what we do is we put A1, B2, and the next term in the bracket is A2, B1. So we write that down. So we have A1, B2 plus A2, B1. and then we had taken I common, so we quickly write that down before we forget, right? So this is actually what we have when we multiply these two terms. This, when we talk about, when we look at addition and subtraction, they seem pretty easy, right? A1 plus b1i plus a2 plus b2i. And when we look at division, when we look at subtraction, let me remove these two things over here. Can I remove them at the same time? I don't think I can. Maybe let me try this. Yeah, can I? Yeah, I can. Cool. So let me remove these as well then. Okay, make things clearer, make things cleaner. Okay, so when we look at addition and subtraction, they seem pretty easy. A1 plus b1i plus a2 plus b2i. When we look at subtraction, that's a1 minus a2i, a1 minus a2 plus b1 minus b2i. So they're pretty easy, pretty straightforward when you ask me. But Z1, Z2, they actually, the terms that we had used, they actually, merged together. So we have A1, we have one term from the first complex number, one term from the second complex number for each of these terms. So it's a little jumbled up. So it's difficult if you don't know the concept or the logic behind these intermediate steps, and it's very difficult to, at least for the first few days of learning complex number, it's very difficult to look at this expression and okay, fine, this will be the final answer. So addition and subtraction, of course, are easier than multiplication. So this is pretty much how multiplication works in the domain of complex numbers. In the next video, we'll be talking about division. Again, if you found multiplication difficult, then I do suggest that you look up this video a few more times so that you're pretty comfortable, because division will be using uh, complex numbers multiplication. Actually, we will be actually doing division in terms of multiplication. So do watch this video and get things down, get things clear. And of course, if you have any doubts, you can write the doubts in the comment section below. I do read comment sections. I am really starting up, so I don't have that many comments, but if you write them down, I will surely get back to you. And next week we'll be looking at division of complex numbers. So see you next week.